Hi students, in this video I'm going to show you how to calculate the slope of a line. We'll do it in two ways. First we'll look at it graphically, and then we'll look at it algebraically using the formula for slope. So you may remember from Algebra 2 that slope is sometimes called the rise over the run. That's the way that we think about calculating it. So basically it's like, how far do you go up for every unit that you go to the right? And it encapsulates the idea of going up a mountain, for example. Like on the horseshoe hike on the steep parts, you are going up a lot in a short distance, but on the flat parts, you're not going up very much over a longer distance. So the way that we calculate slope graphically is, say I have these 2 points. I kind of take a walk from one point to the other, but I think about walking vertically first. So from the point 0, 6, I walk down 1, 2, 3, 4 for every time that I walk over 1, 2, 3. So the rise here in this example is -4, and the run is 3, because in order to go to the right 3, 1, 2, 3, I had to go down 6. So you're sort of looking at the legs of the right triangle that are formed by the 2 points, and the rise is the length of the vertical leg and the run is the length of the horizontal, but you have to pay attention to the sign as well, whether you're going up or down. In this second example, my line goes through the point 1, 2, and it goes through the point 5, 4. And so I go for my walk again. First I walk horizontally, first I want to look vertically, because that's going to be the rise. So how far do I have to go up? 1, 2, 3. So the rise here is +3. And the run is how far I have to go over now to hit the line. So I go over 1, 2, 3, 4. So the run is 4. So the example on the left, the slope was -4/3. The example on the right, the slope was +3/4. So when the line is going down, when it's decreasing, the slope's going to be negative. It's like we're going downhill. When we're going uphill, the slope is going to be positive. So what we basically did here is we looked at the change in the vertical direction. So change in vertical, that's the same as the rise. Another way to say that is the change in y. So this represents the change in y between the 2 points. And then we divided that by the change in the horizontal direction. Which is the change in x. We went from 1 to 5, and that was 4. So these geometric ideas now give us an algebraic way to interpret slope. The change in the vertical, we can calculate this vertical difference by just doing the y values, the difference in the y values. So I might write y1 minus y0 if this point is called x1, y1, and this point is called x0, y0. I take the difference in the y values, so for example 6 minus 2, to get the vertical distance. The change in the horizontal is going to be the difference in the x values. So I do x1 minus x0. So again, another way to say this in words is the difference in y values, and divide by the difference in x values. So let's do a couple examples where we use this formula, and then we'll compare it to the graphical approach. So here I want to find the slope of a line that goes through the points 1, 3 and 4, 5. So 1, 3 will be my x0, y0 in the formula, and 4, 5 will be my x1, y1. It doesn't matter which I pick to be x0, y0, and which I pick to be x1, y1, as long as I'm consistent. So the slope, we usually denote it m, is going to be y1 minus y0, so that's 5 minus 3, divided by x1 minus x0. So that will be 4 minus 1. So the slope is just going to be 2 over 3. Now we can compare this to the graphical approach. So if here's 1, 1, 2, 3, that's the first point on my graph. This is 1, 3, and then I also have 4, 5. So that's 4, 5 is the second one I've graphed, and my line goes through both of these points. So to figure out the slope, I look at the rise, 1, 2, so that length is 2, over the run, 1, 2, 3. See, I've gone 3. And then the slope is just going to be 2 over 3, and it's positive because this is increasing. So sorry about the alarm going off back there. Let me pause while it finishes. Okay, let's do another example using this equation for finding the slope of a line. So we want to find the slope now of a line going through the points -1, 2, and 2, 4. So I'll call the first point my x0, y0, and the second point my x1, y1. And from the formula, this says that the slope m is given by the difference in the y values over the difference in the x values. So I should do y1 minus y0, 4 minus 2, divided by x1, 2 minus x0, -1. 4 minus 2 is 2, and 2 minus -1 is the same as 2 plus 1, so that's 3. So that gives us the slope. And now I just want you to be a little bit careful, because what if I had messed up the order? So let's say I did y1 minus y0, 4 minus 2. But then I did x0 minus x1 by accident. So if I do -1 minus 2, then I would get 2 over -3. I'd get a negative slope. This is wrong. And so you need to be consistent about the order that you subtract. If you do this minus this, then you need to do this minus this. And we'll quickly compare with the graphical. So -1, 2 is the first point, and then 2, 4 is the second. And so our rise, we go up 2, and then over 1, 2, 3. So we get a slope of 2/3. We'll do one last example, and this one is pretty interesting. I want to find the slope of the line through 1, 2, and 3, 2, and I want to know what's special about this line. So clearly something's going to be special. The first thing you might notice is that the y values are the same. So what might that indicate? Well, let's calculate the slope and then we'll draw a picture. So the slope is going to be y1 minus y0 over x1 minus x0. So I'll do 2 minus 2 over 3 minus 1. And what do I get? 0 over 2, which is 0. So the slope of this line is 0. What might that mean? Well, it comes from the fact that the y values are the same, right? If any time I'm looking for the difference in y values, but the y values are the same, I'm going to get a 0 on top. So now if I go to graph these 2 points, I'll graph 1, 2, and then 3, 2. This line is horizontal. So that's what's special about this line. Horizontal. In the next video, we'll talk about some other special lines. What does it mean for a line to be vertical in terms of slope? What does positive slope indicate? What does negative slope indicate? Those are the kinds of things we're getting at. So have a think about that, and we'll confirm your guesses in the next video.